we're going to keep on rolling with more integrals on partial fraction, the usage of partial fractions. So if I take a look at here, I have, if I looked at this integral and said, all right, I want to use something like substitution method, it's not going to work very well because I could take u to be this, but it doesn't really look like it's a great fit for that. So, sorry, I just want to make sure I've written down everything correctly. So what I need to do is I need to follow this partial fraction roadmap. The first thing is I need to use long division as needed. So in the first case, I say, okay, do I need to do long division? Well, the answer is no, I don't, because the degree of the polynomial on top is less than the degree on bottom. So I'm already done. The second thing is I need to factor the denominator. So to factor the denominator, I have to say x cubed minus 4x. Well, those have an x in common, so that'll be an x here, and then x squared minus 4. But if you remember, x squared minus 4 is that difference of squares formula, so I end up with x minus 2, x plus 2. So that's how we factor that. The third thing is to separate the linear factors. Well, I have 3 factors here, so x squared plus 108x plus 108 over x cubed minus 4x can be rewritten as a over x plus b over x minus 2 plus c over x plus 2. So I have 3 distinct linear factors. And none of them have multiplicity more than 1. Like I don't have a squared here or anything like that. So I don't have to worry about repeated terms. And then finally, I need to separate any quadratic factors. But if I look, each of those are linear factors because each of these is a degree 1 polynomial. So that's already done. So finally, we need to separate into step 5. So the first piece of step 5, part A, is going to be to multiply the denominator on both sides. So I'm going to say x squared plus 8x plus 108. So I'm going to multiply that by the denominator. And then what I want to do is I want to cancel everything that cancels. What you're always going to, sorry, this is not a plus, that's an equal sign. What you're going to find is that on the left side you should always cancel everything. You should only be left with the numerator. So you should be left with x squared plus 108x plus 108. And then on the right side, because all those should cancel, on the right side, in that case just the x cancels. So I have a x minus 2, x plus 2. On the b, I find the x minus 2's cancel. So I have plus b x plus 2. And on the c side, I see the x plus 2's cancel, leaving c x minus 2. So now I have multiplied through, so what I need to do next is pick convenient values. So let's do that now. What I'm going to do is I'm going to say, all right, what happens, I want to get rid of things. So usually one of the nice things to do, if you have just an x as a factor, just use x equals 0. So that'll be one factor I'll choose. And when I plug in x equals 0, this disappears, and that stays. So 108 equals a times negative 2 times positive 2, because again those are 0. And then these all vanish, right? Because that's times 0 times 0. So if I have 108 is negative 4a, that tells me that a, I believe that's negative 27. Make sure I do that right. Yep, cheat sheet says I'm doing good. So the next piece, all right, now I know what a is, but let's make some other things disappear. Well, if I want to make a disappear, I can either use plus 2 or minus 2. It doesn't matter. So let's just use plus 2 for now. So if I use plus 2, I get 4 plus 216 plus 108 equals, that's 0. So b times 2 times 4. But c also vanishes, right? Because when I plug in 2, that also vanishes. So now I end up with, what is that, 220? So 328 is equal to 8b. If we divide both sides by 8, it looks like b is 41. All right, it checks out. So the next thing we want to do is to say, okay, I've got A and I've got B, so I need to pick something that's going to make A and B both vanish, but doesn't make C vanish. So if I pick negative 2, that'll vanish and that'll vanish. So I'm going to pick x equals negative 2. So in doing that, I get 4 minus 216 plus 108 equals, so it vanishes, c times negative 2 times negative 4. So in doing that, I get negative 108. So negative 104 equals negative 8c. So dividing that out, we get what? 13? Is that right? 13? Seems wrong. Negative 13? Oh yeah, it's negative 13. Negative 2, negative 4 is positive 8. So that tells me C is negative 13. Alright, so now that I have A, B, and C, what I can do is I can set up my integrals. I can say, okay, well, I know that it's this. This is my format. So I'm now doing the integral of negative 27 over x plus 41 over x minus 2 minus 13 x plus 2 dx. So each of these is a log integral. So we end up with negative 27 natural log of x. We could use a u sub here. Hopefully you're starting to recognize by now that if it's just x plus a number or x minus a number, that's just a log shift, right? So there's not really, you can use a u sub, but I'm hoping you're starting to recognize the pattern so you don't have to, you can just kind of skip there yourself. And we end up with negative 27 natural log of x, 41 natural log of x minus 2, minus 13 log of x plus 2, all those are absolute value, plus your arbitrary constant. And it matches my cheat sheet, so I'm going to trust it. But that's the idea. Now we have 3 factors, so let's keep rolling. Maybe we'll end up with something more complicated.